We're all carrying these little supercomputers around in our pockets, but some of the most amazing AI they use is totally invisible. It works right on the device itself, and most of the time, we don't even realize it's there. So today, we're going to pull back the curtain and find that hidden intelligence.
Oh, we've all been there, right? You ask your phone something super simple and you get this dreaded message. It is the classic moment of modern tech frustration. A perfect reminder that our smart devices can feel pretty clueless the second they lose their link to the big brain in the cloud.
And it really makes you wonder, doesn't it? Why does a device that has more power than the computers that sent us to the moon still need to phone home just to set a timer? Well, the answer is all about how AI used to work. But a huge shift is happening right now, moving all that brain power from far-off servers directly into our hands. So let's break down the difference, because this is really the key. Cloud AI is powerful, sure, but it's also slow. It has to have the internet, and you have to send your personal data to some server somewhere. On-device AI, on the other hand, is a total game changer. It's lightning fast, it works when you're completely offline, and this is the big one, your data never leaves your phone. This isn't just about convenience, it's a massive leap forward for privacy and performance. And what's so cool is that this powerful, private AI isn't some science fiction tech that's years away. Nope. It's already running on the phone you're probably holding right now. So, come on, let's go find this hidden intelligence at work. The real magic behind on-device AI all starts with the hardware. See, it's not running on the main chip that powers your apps. It uses these tiny, specialized, super low-power chips that are built for one job, running AI models without killing your battery. This chip from an MIT research paper is a perfect example. It's basically the granddaddy of things like the Apple Neural Engine, with dedicated parts just for speech recognition and something called voice activity detection. Okay, so we've got the efficient hardware, but that just leads us to the next massive problem. An always-on assistant can't actually be listening to and processing every single sound around you 24/7. Your battery would be dead by lunchtime. So, how does it know when it's supposed to perk up and pay attention? Well, the hero of our story is a little piece of tech called Voice Activity Detection, or VAD for short. Just think of it like a bouncer or a gatekeeper for your phone's microphone. Its only job is to listen for one thing and one thing only, the sound of a human voice. It ignores everything else. And it runs constantly, using an absolutely minuscule amount of power, just waiting for you to say something. Now, if you lived inside a perfectly quiet sound booth, a VAD's job would be incredibly easy. It would just be on the lookout for a clean, simple audio waveform like this one. When it sees that distinct pattern, it knows, hey, someone's talking. Easy peasy. But of course, we don't live in a sound booth. The real world is an absolute sonic mess. A VAD has to pick your voice out from the clatter of a coffee shop, from passing traffic, from the TV blaring in the background, even from other people talking over you. Developers have found some crazy edge cases, like one team that discovered their VAD kept getting triggered by strong wind just hitting the microphone. Now, this is where it gets really interesting. A key finding from that MIT research is that the VAD itself uses almost no power. The real energy cost comes when it messes up. Every time it thinks it hears speech when there isn't any, that's a false alarm, it has to wake up the big, power-hungry speech recognition system. And those false alarms waste way more energy than the VAD itself ever uses. So accuracy isn't just about getting it right. It's the #1 factor for your phone's battery life. So to get that kind of accuracy, researchers had to go way beyond just looking at volume levels. They actually trained neural networks to recognize the unique texture of sound. This slide is a brilliant way to see it. These are basically pictures of sound frequencies. To a trained AI, that top image has the unmistakable pattern of human speech, while the bottom one is clearly just background noise. The model learns to tell them apart, even when they're all mixed together and the voice is barely a whisper. And the result of all this incredible research? We get these powerful open-source models that anyone can use, like Solero VAD. I mean, this thing is a marvel of efficiency. It processes audio in less than a millisecond. The whole model is only 2 megabytes. It's super accurate. And since it's open source, developers can just grab it and build amazing new things. Now, don't let this scare you, but underneath all of this is some seriously complex math. This formula here is just a little peek into the probabilistic models that make these systems tick. It's basically how the AI calculates the odds of what it's hearing. It looks intimidating, and, well, it is. But, and this is the absolute beauty of it,
A developer using a modern tool never has to see any of that complexity. All of that intense math, all that deep research, it gets bundled up and hidden behind a single, clean line of code. This is how progress happens. Brilliant people figure out the hard stuff, and then they package it into simple tools so everyone else can build on top of it. So let's just quickly put it all together. The modern on-device AI stack looks something like this. At the bottom, you have the specialized hardware, like the Apple Neural Engine. Layered on top is a framework like CoreML that lets apps talk to the hardware. Then you have the tiny, efficient AI model itself, like our friend the Silero VAD. And wrapping it all up is an SDK that makes it easy for a developer to actually use it in their app. But our story isn't quite over. Just because your device is listening correctly, that doesn't mean it actually understands correctly. During a big Apple presentation, an engineer was showing off a chess app he built, and he said this very specific phrase. And the app heard, "Play the album." So what happened? Well, the general-purpose speech recognition model on his phone was trained on billions of common phrases, including tons and tons of requests to play music. It had probably never heard of the Albin counter gambit, so it just guessed the most likely thing it could be. So Apple created this incredibly elegant solution. They gave developers a way to customize that on-device model. A developer can just give the system a list of unique words for their app, like a bunch of chess openings. Then the app fine-tunes the model with that new vocabulary, and it all happens right there, on the user's device. Nothing ever gets sent to the cloud.
And that's the real payoff. We've come full circle. We now have a system that can listen efficiently and privately using a VAD, and it can understand your unique, specific words with a customized model. It's personal, it's accurate, and it's all completely private.
And this brings us to one final, really big thought. We've just seen that our devices can now listen for and understand context in a way that's hyper-efficient and totally private. So the question isn't really if it can listen anymore. The real question is, what should we teach it to listen for next? What new, truly personal AI experiences does it unlock for all of us? The possibilities are really just beginning.